this topic is about being able to identify exact trigonometric values. We also need to be able to solve trigonometric equations in both degrees and radians, and to solve quadratic trig equations. I will go through concepts and examples. Feel free to pause as you wish. Okay, to be able to identify exact trig values, we need to look at these two special triangles. So this is an equilateral triangle. An equilateral triangle is obviously of equal side lengths, so all the lengths are 2. And because it's an equilateral triangle, we know all these angles are 60 degrees. Now, if I split this equilateral triangle in 2, then I get this triangle, which is a right angle triangle because I split it up in 2. And this would be 60 degrees. And because this has been halved here, this will be half of 60, which is 30 degrees. Okay, we also know this side length was 2. Because the base will be 1 because it's been split in 2, so half of 2 is 1. And due to Pythagoras, this must be root of 2 squared, take away 1 squared, which is root of 3. Okay, now if I use this angle, that means sine 30 degrees will be equal to opposite, which is 1 over hypotenuse, which is 1 over 2. Okay, cos of 30 degrees will be equal to adjacent, which is root 3, over hypotenuse, which is 2. Tan of 30 degrees will be opposite, which is 1, over adjacent, which is root 3. Now, we don't like that, so we need to rationalize it, which gives, if I multiply top and bottom by root 3, I get root 3 over 3. In a similar way, if I do sine of 60, so I'm looking at the 60 degree angle, is equal to opposite over hypotenuse, which is root 3 over 2. Okay, cos of 60 degrees is adjacent over hypotenuse. So adjacent is 1 over hypotenuse, which is 2. And the last one, which is tan of 60 degrees, is equal to opposite, which is root 3 over adjacent, which is 1, which is just root 3. Okay, so you get the values of sine 30, so the trig values of 30 and 60 using this equilateral triangle and halving it. If I want to work out 45 degrees, I look at a unit triangle, a right angle unit triangle. So unit triangle means the side lengths based on the height is 1, and this angle is 45 degrees, which also means this angle is also 45 degrees. Okay, now using this triangle, we can work out sine of 45 degrees. Okay, sine of 45 is opposite over hypotenuse. The first thing I need to do is work out hypotenuse. We're using Pythagoras, which is root of 1 squared plus 1 squared, which is root of 2. So sine 45 is opposite over hypotenuse, which gives me 1 over root 2. If I rationalize the denominator, then I get root 2 over 2. Cos of 45 degrees is equal to adjacent over hypotenuse, which is again 1 over root 2, which is root 2 over 2. And the last one is tan of 45 degrees is opposite over adjacent, which is 1 over 1, which is equal to 1. So now we've got all the trig values for 30, 45, and 60. If we were to put it into a table, okay, so if I draw a table, sine, cosine, tan. Let's start from 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Then we know sine graph starts from 0. Sine of 30 is a half. Sine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And 90 all the way goes up to 1 in the sine graph. Now the cos graph starts off at 1. Cos of 30 is root 3 over 2. cos of 45 is root 2 over 2. Cos of 60 is a half. And cos of 90 goes down to 0. Now, if you look at the sine line, the cosine line, you'll see that this line has been reversed to get the cos line. Yeah, so it's gone backwards to get the cosine one. Okay, tan starts off 0. Okay, tan of 30 is equal to root 3 over 3. Tan of 45 is 1. Tan of 60 is root 3. And tan of 90 is undefined. So that would be how your table looks like. And don't forget, this is also true for radians. So over 4, pi over 2 radians, pi over 3 radians, and pi over 6 radians. Okay, so they're all equivalent to in radians as well. Okay, if you want a short way to memorize this, so I think of it like that. If I have sine, the short way, so there's a shorthand way to memorize it. If I have sine, cosine, and tan, then what I think of it is, if I have, it's the same thing as 0 over 4, 1 over 4, 2 over 4, 3 over 4, and 4 over 4. So if you want to find out, so this is 0 degrees, 30 degrees, undo, 45 degrees, 60 degrees, and 90 degrees. If I want to find sine of 45 degrees, it's root 2 over root 4. Root 2 over root 4 simplifies to root 2 over 2. Okay, the cosine one is the opposite way around, so the same thing, but the opposite way around. 4 over 4, 3 over 4, 2 over 4, 1 over 4, and 0 over 4. So this is a shorthand way of memorizing it. Don't ever write it out like that. And tan is just sine theta over cos theta, which you learn later on. So all you have to do is, to get tan theta is, for example, for the first one is root 0 over 4 divided by root 4 over 4. Okay, which gives you obviously 0. So the first one will be 0, so on. Okay, so that's a short way. So don't memorize this though, as in it's just a short way if you want to get an answer very quick. Okay, so let's go through the first example of solving trig equations with the radians. Okay, so let's solve sine 3 theta is equal to root 3 over 2. Okay, first of all, I know there's a inner function, so I need to do a substitution. So let u be equal to 3 theta, then sine of u is equal to root 3 over 2. Because I've got in terms of u now, I need to adjust my range. So my right range goes at the moment from 0 to 2 pi. So if I multiply theta by 3, I get 3 theta is from 0 to 6 pi, which means my u runs from 0 to 6 pi. Okay. So I need to find out what u is first, what the first value of u. So if I do inverse sine of root 3 over 2, then u is equal to pi over 3 is my first value. Okay, and to draw the sine graph, so going from up to 6 pi, remember every 360 it repeats itself. So pi over 3 is somewhere here. This is pi over 4. So pi over 3. Let's just call this pi over 3. We draw a line. So it hits the curve 6 times. We already got the pi over 3. So we need to find the rest of them. So this one, because this is pi over 3, that must be pi take away pi over 3. which is equal to 2 pi over 3. This one must be 2 pi plus pi over 3, which is equal to 7 pi over 3. This one must be 3 pi take away pi over 3, which is equal to 8 pi over 3. This one must be 4 pi plus pi over 3. 4 pi plus pi over 3, which is 13 pi over 3. And the last one here must be 5 pi minus pi over 3, which is equal to 14 pi over 3. So we've got 6 solutions. So we know that 3 theta is equal to pi over 3, 2 pi over 3, 7 pi over 3, 8 pi over 3, 13 pi over 3, and 14 pi over 3. So all I need to do is divide by 3 to get my final answer. So once I divide by 3, I get pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. So these would be my solutions. Okay, next example. So cos theta minus pi over 3 is equal to negative 0.25, where theta runs from minus pi to pi. Again, we have to do a substitution. So let u be equal to theta minus pi over 3. Then cos of u is equal to negative 0.25. I need to adjust the range, so minus pi is less than theta, which is less than pi. So theta minus pi over 3 will be between 2 pi over 3. So when I do pi minus pi over 3, I get 2 pi over 3. And in the left-hand side, I get minus pi take away pi over 3, which is minus 4 pi over 3. Okay, so u runs between 2 pi over 3 and negative 4 pi over 3. Now these numbers, I can't do them in my head. So I use my calculator to figure out what 2 pi over 3 and negative 4 pi over 3 are. So if I put 2 pi over 3, I get this number, 2.0943 and minus 4.188. So this is my range between those numbers, okay? Because I can't identify what minus 4 pi over 3 and 2 pi over 3 are in my head. Okay, so first thing I need to do is to find u, I need to do inverse cos of negative 0.25, which in my calculator, it gives me a value of u is equal to 1.823 to 3 decimal places. 1.823. So if I sketch this is within my range. I can see clearly that's within my range. So I need to go, if I draw my okay, 1.82 somewhere here. So this is my first value, 1.82. To find out this length, I need to do 1.82 take away pi over 2. So 1.823 minus pi divided by 2, which is 0.252. So I know this part is 0.252, the distance between the x-intercept and there, okay? That means if I draw a line going across, I need to first find this point, which is clearly negative So this is clearly, because this is 1.823, this is clearly negative 1.823, and that is within my range. So that is an answer, negative 1.823. Okay, now I need to find, obviously this one, oops, undo. I need to find this one. Okay, because it's symmetrical, I know this must be 3 pi over 2 take away 0.252. Now you get a value of 4.46, which is outside the range, so we can't have that one. If that is 4.46, that is also negative 4.46. Again, that would be outside the range. So the only two solutions are 1.823 and negative 1.823. Okay, so that means theta minus pi over 3 is equal to 1.823 and negative 1.823, which means theta will be equal to 2.87 to 2 decimal places and negative 0.78 by adding pi over 3 to these numbers. Find in radians to 2 decimal places the value of theta in the interval 0 to 2 pi. So first one and B. Okay, A. So let u be equal to the inner function, which is theta plus pi over 4. Then sine of u is equal to 0.4. Theta runs from 0 to 2 pi, which means theta plus pi over 4 will run from pi over 4 to 2 pi plus pi over 4, which is 9 pi over 4. If I put these endpoints of the range into my calculator, because I don't know what 9 pi over 4 is, it's approximately 7.068. And pi over 4 is 0.785. So I'm looking for numbers, solutions between 0.785 and 7.064. Okay, if I want to find u, I'm doing inverse sine of 0.4. And when I put that into calculator, I get 0.412 radians. The question is in radians. Okay, and that number is not in my range. Okay, as you can see, it's not in my range. So I've crossed out that solution. I need to draw the cosine rule to find my sine graph to find all my other solutions. So sine graph. Okay, so sine graph starts off at 0, goes up to 1, back to 0, minus 1, 1 and 0. So that was my first solution, which is outside the range, so we don't want that. So the next one is here. Because this is 0.412, that is also 0.412. So to find this one, it's pi take away 0.412, which gives me a value of 2.730 radians, which is within my range. Okay, I need to find the next one, which is here. I know this is 0.412. So that must be 2 pi plus 0.412, which is a value of 6.695 radians. And the next one here will be outside my range, so I don't need to calculate that one. So that means theta plus pi over 4 is equal to 2.730 and 6.695. So if I want to find theta, I need to subtract pi over 4, which means I get 1.94 to 2 decimal places, but I subtract pi over 4 from 2.730, and I get 5.91 radians when I subtract pi over 4 from 6.695. So those are my two solutions. Now part B. So I've got 1 minus cos 2 theta is equal to 0. So if I rearrange this, I get 1 is equal to 3 cos 2 theta. So if I swap it around and divide by 3, I get cos 2 theta is equal to 1 over 3. Let u be equal to 2 theta. Then cos of u is equal to a third. I need to adjust my range. Theta is between 2 pi and 0. So 2 theta will be between 4 pi and 0. So u is between 4 pi and 0. So we're looking at the cosine graph. One, two, three, four. 1, 2, 3, 4. Cosine graph looks like so. Okay, so u is equal to inverse cos of a third. If you put that into a calculator, you get u is equal to 1.231 radians. 1.231. Okay, so it hits it somewhere here, which is 1.231. So this is 1.231. I need to draw a line and find all the other points. So this one will be, this is 1.231. This one will be 2 pi, take away 1.231, which is a value of 5.052. And then the next point is here, because we know this is 1.231. It's 2 pi plus 1.231, which is a value of 7.514. And the last one, which is here, is equal to 4 pi take away, because this is 1.231. 4 pi take away 1.231, which is 11.335. So because 2 theta is equal to 1.231, 5.052, 7.514, and 11.335, then theta, by dividing by 2, you get theta is equal to 0.62 radians, 2.53 radians, 3.76 radians, and 5.67 radians. So these are my solutions. Okay, next question. Solve for x in the interval 0 to pi. The equation sine 2x minus pi over 3 is equal to half. Give your answer in terms of pi. Okay, again, this is my inner function. So let u be equal to 2x minus pi over 3. Then sine of u is equal to a half. 0 is less than x, which is less than or equal to pi. So if I multiply by 2, I get 2x is between 0 and 2 pi. And 2x minus pi over 3 will be between minus pi over 3 and 2 pi take away pi over 3, which is 5 pi over 3. So u runs from negative pi over 3 to 5 pi over 3. Okay, so if I want to find out u is equal to inverse sine of a half, which is equal to pi over 6. Sketch the sine graph. Okay, because 5 pi over 3 is less than 2 pi, I only need to draw it up to 2 pi and negative pi over 2. So it looks like so. That is enough. So we're looking for half. Half is somewhere here, let's say. Then we only have one other point we need to find, which is here. We know this is pi over 6. So this is pi over 6, which means that is pi take away pi over 6, which is equal to 5 pi over 6. So that means 2x minus pi over 3 is equal to pi over 6 and 5 pi over 6. So 2x, we have to add pi over 3 to both. When I add pi over 3 to both, I get 3 pi over 6 and 7 pi over 6. Okay, then divide by 2. So if I divide by 2, I get 3 pi over 12 and 7 pi over 12, which can be simplified to pi over 4 and 7 pi over 12. Okay, next question. Okay, when I look at the next question, I can see straight away it's a quadratic. So first thing I need to do is factorize it. So if I factorize it, it's just like treating x squared, x as y. So I need 2 sine x here, which means I must have sine x here. I need 2 things that multiply to give you 2. So if I put a plus 2 here and a plus 1 here, then if I expand it, I do get 2 sine squared x. I get the 4 sine x plus sine x, which is 5 sine x, and I also get the 2. So that's right. So either 2 sine x plus 1 is equal to 0, or sine x plus 2 is equal to 0. This means, let's deal with the second one first. Sine x is equal to negative 2. Now that means there are no solutions, therefore no solutions. So how do I know there are no solutions? Because sine x, the range of sine x is from minus 1 to 1, because sine x runs from minus 1 to 1. So you don't have a value which gives you a sign of the value to be minus 2. So that's not true, okay? So we can't have a solution there. Okay, if I solve this one, I get 2 sine x is equal to negative 1, which means sine x is equal to negative a half. X must be inverse sine of negative a half. I put that into my calculator, I get minus pi over 6, which is outside my range, so I can cross it out. I need to use this value to find my other values. Okay, so that means if I sketch my graph, obviously the sine graph looks like so. And if I have this there, so it was minus a half, which was here. This was my first solution, so I'm trying to find my other solutions. I know up to this part is pi over 6. So if I need to find this part, this is pi over 6. So it must be pi plus pi over 6 for the first solution, which is equal to 7 pi over 6, which is within my range. And to find my next one, which is here, so I know this is pi over 6, so this one must be 2 pi take away pi over 6, which gives me a value of 11 pi over 6, again, which is in my range. So that means my two solutions are 7 pi over 6 and 11 pi over 6. Next question. So 2 cos squared minus 5 cos theta plus 2 is equal to 0. So again, it's a quadratic. I'm going to see if I can factorize it. So 2 cos theta in one, cos theta in the other one. I need two numbers that multiply to give you 2. And then the product after when I expand it gives me minus 5. So I'm thinking it's minus 2 here and minus 1 here. If I expand here, I get 2 cos squared theta plus 2. And from the middle terms, I get minus 4 cos theta minus cos theta, which gives me minus 5 cos theta. So that's right. So either 2 cos theta minus 1 is equal to 0, or cos theta minus 2 equals 0. Let's deal with the second one first. Cos theta is equal to 2, therefore no solutions. Okay, so let's go back to the first one. 2 cos theta is equal to 1, which means cos theta is equal to half. Theta is equal to inverse the cos of the half, which is equal to pi over 3. You either know it from your exact trig values or you use your calculator to get your answer. If I draw the cos graph from minus 1, so from 0 to 2 pi, okay, then pi over 3 is somewhere here. Okay, so this is pi over 3, which means this is pi over 3. It's a sketch, so don't worry too much about it. So that part must be 2 pi. This solution must be 2 pi minus pi over 3. 2 pi minus pi over 3 is 5 pi over 3, which means theta must be equal to pi over 3 and 5 pi over 3. And they're within my range. Okay, so next one is tan squared 2 theta is equal to 3. Solve for theta in the interval 0 to 2 pi. Okay, so if tan squared 2 theta is equal to 3, this is if and only if tan 2 theta is equal to plus or minus root 3. Okay, so when we square root both sides, we get plus or minus, okay? So that means there's two solutions, two sets of solutions, which is either tan 2 theta is equal to root 3, or tan 2 theta is equal to negative root 3. So we get two sets of solutions. So let's solve each one separately. So let u be equal to 2 theta, then tan u is equal to root 3. Okay, and because theta goes from 0 to 2 pi, then 2 theta will go to 0 to 4 pi. So u must run from 0 to 4 pi. Okay, u is equal to inverse tan of root 3. Put that into your calculator, you get u is equal to pi over 3. Now you can draw the tan graph if you want, but remember tan graph repeats itself every 180 and it's the same shape throughout. So all you have to do is add pi over 3 to get the next one. So add pi to get the next one, yeah? So keep adding pi to get the next one. So pi over 3, if you add pi, you get the next one, which is 4 pi over 3. If you add pi again, you get the next one, which is 7 pi over 3. And that's still within the range because we want it all the way up to 4 pi. If you add pi again, you get 10 pi over 3. If you add pi again, you're going to get over 4 pi because you're going to get 13 pi over 3, which is more than 4 pi. So we stop there. So that means these are the four values that you get. So 2 theta is equal to pi over 3, 4 pi over 3, 7 pi over 3, and 10 pi over 3. So if you divide by 2, you get pi over 6, 4 pi over 6, which simplifies to 2 pi over 3, 7 pi over 6, and 10 pi over 6, which simplifies to 5 pi over 3. Okay, do the same thing with this one, with the second equation that you got. So let u be equal to 2 theta, then tan u is equal to negative root 3. Again, because of the value of minus pi over 3, which is outside your range. Ignore that one. But you add pi to get the next one, which gives you 2 pi over 3. Add pi again to get the next one, which is 5 pi over 3. Add pi to get the next one, which is 8 pi over 3. Add pi to get the next one, which is equal to 11 pi over 3. If you add pi again, you're going to get 14 pi over 3, which is greater than 4 pi. So stop there. That means 2 theta is equal to 2 pi over 3, 5 pi over 3, 8 pi over 3, and 11 pi over 3. All I need to do is divide by 2. When I divide by 2, I get pi over 3, 5 pi over 6, 4 pi over 3, and 11 pi over 6. Which means my final solutions are, if I put them all together, is pi over 6, 2 pi over 3, 7 pi over 6, 5 pi over 3, pi over 3, 5 pi over 6, 4 pi over 3, and 11 pi over 6. So these are my final solution. Okay, next question. Show that the equation 2 cos squared x plus cos x minus 6 is equal to 0 has no solutions. Okay, so if I'm trying to solve a quadratic, the first thing I'll try to do is factorize it. So I get 2 cos x and cos x in 1. I need two things that multiply to give me minus 6 and add to give me 1. So it's going to be positive 3, negative 1. Or negative 3 positive, negative 3 positive 2. So it must be negative 3 here and positive 2 here. So if I expand this, I get 2 cos squared x, I get the minus 6. From the middle terms, I get plus 4 cos x minus 3 cos x, which is positive cos x. So I get either 2 cos x minus 3 equals 0, or cos x plus 2 is equal to 0. If I rearrange this, I get cos x is equal to negative 2. Therefore, no solutions, as cos x runs from, the range of cos x is between minus 1 and 1. This one, if I rearrange it, I get 2 cos x is equal to 3, which means cos x is equal to 3 over 2, which means cos x is equal to 1.5. Therefore, no solutions. As again, cos x runs from minus 1 to 1. No solutions. As cos x is equal to 1.5 and cos x is equal to minus 2 is outside of range. Okay, so that would be it. Solve the equation cos squared 3x minus cos 3x is equal to 2 in the interval minus pi to pi. I don't like this. There's the inner function there, so let's get rid of it by substituting u equal to cos 3x. And then we have cos squared u minus cos u is equal to 2, which means cos squared u minus cos of u minus 2 equals 0. I need to adjust my range. So minus pi is less than or equal to x, which is less than or equal to pi, which means 3x is between 3 pi and negative 3 pi. So u is between 3 pi and negative 3 pi. If I factorize this, then I've got cos u and cos u. I've got minus 2 here and plus 1. So if I expand this, I get cos squared u minus 2. And then I've got minus 2 cos u plus cos u, which is negative cos u. So either cos u plus 1 equals 0, or cos u minus 2 equals 0. Let's straight away solve this one because we know straight away. Therefore, no solutions for this one because cos u is equal to 2, as cos u goes from minus 1 to 1. If I've solved this one, I get cos u is equal to negative 1. Then u is equal to inverse cos of negative 1. Now I know that thinking of the cos graph without even sketching it, I know that it's at 3 pi. So at minus 1, it's at minus 1 at pi. Sorry, at pi. Yep, it's minus 1 at pi. So think about the graph. If I draw it out, even without sketching, you should know this, but let's sketch it out. So we need it to go from 3 pi. So this is pi over 2, this is pi. This is pi, sorry, this is 2 pi. This is 3 pi, so cos graph. So you know. It's at minus 1 at pi. So the next time it's at minus 1 will be if you add 2 pi, which will be at 3 pi. Going backwards, the next time will be a minus 1. Is if you subtract 2 pi from here, from the pi, which gives you negative pi. The next one on the other side will be negative 3 pi. And because 3 pi and minus 3 pi are included in the inequality, we can include these solutions. Okay, which means 3x is minus 3 pi, minus pi, positive pi, and positive 3 pi. Which means x, if we divide by 3, we get minus pi over 3, pi over 3, and pi. So these would be your solutions. Okay, the last example. We've got tan squared minus 2 tan x minus 4 is equal to 0. Show that tan x is equal to p plus or minus root q, where p and q are numbers to be found. So if we've got tan squared x minus 2 tan x minus 4 is equal to 0, then in this case the coefficient of tan squared x is 1, the coefficient of tan x is minus 2, and the constant on the at n is minus 4. Then using the quadratic formula, because tan x is the unknown, then that tan x is equal to minus b plus or minus root of b squared minus 4ac over 2a, which means it's equal to minus 2 plus or minus 2 squared minus 4 times 1 times minus 4 all over 2 times 1, which means we've got 2 plus or minus 4 plus 16 is 20 all over 2. root 4 root 5, which is 2 root 5 over is I okay, B. Hence show that the equation tan squared x minus 2, tan squared minus 2 or tan x minus 4 is equal to 0 in the interval 0 to 540. Okay, so there's two sets of solution. The first solution is when tan x is equal to 1 plus root 5. So x will be inverse tan of 1 plus root 5. So if I put that into my calculator, I get x is equal to 72.8 degrees. If I want to find the next one, I need to add 180. So add 180 to get the next one, which is 252.8. Again, I need to add 180 to get the next one, which is 432.8. If I add 180, I'm going to get over 540. So those are all my solutions in the range. My second set of solutions comes from tan x is equal to 1 minus root 5. So x is equal to inverse tan of 1 minus root 5, which gives me a value of minus 51.0 degrees in my calculator. This is outside my range. So I need to add 180 to get the next one, which is 129.0 degrees. If I add 180 again, I get 309 degrees, 0.0 degrees. And if I add 180 degrees again, I get 489.0 degrees. If I add 180 again, I'm going to go outside.